problem, longest subarray of 1's after deleting one element. And given these numbers right here, so if we remove one element here, then the longest is 3. So we can, for given we have a constraint, this is a number 0 or 1. So yeah, let's take a look at this example. So if we remove the first one, the longest will be this 3, but if we remove this one, then the longest will be this 5 ones. So the answer is 5. So we are keeping track of the longest one. This is a perfect problem for sliding window. So we will expand right if our condition is, if our window is valid. If it's not valid, we will shrink left. So let's jump on this. What do we need? We need our zeros, because like we are keeping track of zeros, how many of in here. So let's say it's like when we are starting, if our window is valid, then we are shifting to right, and until our windows becomes invalid, then we will shift like in this example right here. So first one, we're removing this one, then we're going up to here, then we can see that there's another one right here, and we are keeping track of the maximum of it. Then we are shrinking left, because like this, in this one our windows becomes invalid, because like we're only allowed to remove only one. So we will shrink to left, then we will start from here, then this one gets removed, then we'll be keeping track of this 5. So initially 0, then to keep track of our max, we need to have our max as well. So let's do our loop. So we will start from until I is smaller than num's length, so I plus plus. So this is our, if window is valid, then we are shifting right, and then we will count our window, our zeros. So if nums I, if we face in 0, then count our 0. So we are counting our 0, and we need also another window, because which is shrinking to left. So initially, let's have for our left side of the shrinking window, initially J was just right here, then we were going to right and right and right until our windows got invalid. So while our 0 is bigger than 1, which means because we are only allowed to have 1 to remove. So so if it is more than 1, then our window is invalid. What do? We say until we face another 0 in here, then we will decrement our 0. So initially J was right here, our left side. If we went up to here, then we saw another 0, which our zeros got incremented. So now we go inside our condition here, where it is saying 0 is more than 1, because this is invalid. Then we need to shrink left. So we can do J plus plus in here. We are moving the left side of it. We are moving to here, then we're to here, we're moving to here, until we see another one, which is here, this one. Then we are decrementing our 0. So that's how this part is working. And once everything is complete, then our maximum will be math maximum out of this max So in here we can keep track of our maximum, which is maximum math max. This given max previously was assigned, or with our I negative j, and in the end we can just return our max here. Perfect. Let's submit our code.